Good day everyone. Again, I'm Sir Gilbert. This video lesson is intended for those students who are said to be online asynchronous learners, those who were not able to attend real-time online teaching based on their self-learning module. This modular teaching through a video lesson will serve as our strategies that are responsive to the special educational needs of learners in this time of pandemic. As such, what has been written in the module will be presented here. Thus, without further ado, let us now start the lesson. Hello grade 7 learners! Today is another opportunity to enjoy learning mathematics. I'm Sir Gilbert, your mathematics grade 7 teacher, and here to guide you in today's lesson. Are you all ready? Bring out your pen, your self-learning module. Together, let's explore the concept of finding the solution of linear equation and inequality in one variable. For this lesson, here is our most essential learning competency. The learner finds the solution of linear equation or inequality in one variable. This is in connection with your Quarter 2, Week 9 module. To the learners, read the simple instructions below. Before we start the lesson, let me first read to you the expectations after going through this module. This module is designed to help you master the following skills. Define linear equation in one variable. States and illustrate the different properties of equality. States and illustrate the different properties of inequality. Finds the solution of linear equation in one variable and finds the solution set of linear inequality in one variable. After going through this module, you are expected to first tell what property of equality and inequality is illustrated in a statement. Number 2, fill in the blanks with correct expressions indicated by the property of equality and inequality to make a true statement. Number 3, solve the equations by supplying a missing terms. Number 4, find the solution of linear equation in one variable by showing a concrete solution. Number 5, find the solution set of linear inequalities in one variable by showing a concrete solution and conclusion in the form of a set builder notation. First, you have to answer the pre-tests. Choose the letter of the correct answer. Write the chosen letter on a separate sheet of paper. Choose item 1, 2, 3, 4, and 5. back to your previous lesson, like the definition of an equation. An equation is a mathematical sentence indicating that two expressions are equal. The symbol equal sign is used to denote equality. For example, 5x equals 9. Is it an equation? Yes, because of the equal sign. 5 minus 1 equals 2. Is this an equation? Again, yes, because of the equal sign. And 7 minus 2a equals 3. Okay? This is also an example of an equation or equality because these three examples use the symbol equal, which denote equality. Another one is the inequality. It is also a mathematical sentence indicating that two expressions this time are not equal. What are the relation symbols used for this inequality? So the relation symbols are lesser than or equal to, greater than or equal to, and not equal to are used to denote inequality. Can you give an example? Okay, I will give you an example. 5x is lesser than 9. Okay, is it an inequality? Yes, because it uses a relation symbol lesser than. Another thing is 3b minus 1 is greater than 2. It's also an inequality. 7 minus 2a is lesser than or equal to 3. It's also an inequality. And 2x plus 1 is greater than 4 but lesser than 7. It's also an inequality, though it has two relation symbols, but still it's inequality. This time, let's have a simple recall on what you have learned in the previous lesson. All you have to do is select the letter of your choice. I will read the questions, then you will be given 5 seconds to decide. Okay, get ready. It is a symbol used to denote equality. Your time starts now. Okay, if your answer is A, sorry, better luck next time. But if your answer is B, again, sorry, till next time. But if your answer is C, okay, congratulations, you got it correctly. Let's have another one. It is a mathematical sentence indicating that two expressions are not equal. Ready? Go! Okay, if your answer is A, sorry, it's a wrong answer. But if your answer is C, again, sorry, better luck next time. But if your answer is B, congratulations, you got it correctly. Let's have the introduction of the topic. A linear equation in one variable is one which can be written in the form ax plus b equals 0, where a and b are real number constants, and a should not be equal to 0. Exempli gratia, 3x minus 2 equals 7, and x plus 5 equals negative 1. These two examples is considered a linear equation in one variable, simply because there's a variable x in the first example, and also a variable x in the second example. And a should not be equal to 0. In example number 1, the a is 3, meaning that's the numerical coefficient of x. And in number 2, 1 is the numerical coefficient of x. And a should not be equal to 0 because once the numerical coefficient is 0, the result of the first term will be equal to 0. There will be no longer a variable in that expression. Same thing will happen for example number 2. On the other hand, 3x minus 2 is greater than 7, and x plus 5 is lesser than or equal to negative 1 are inequality in one variable. When a mathematical sentence contains a variable, it becomes an open mathematical sentence. A variable is a symbol for a number, unless we know what number the variable stands for. We cannot specify the quantity represented by the open mathematical sentence, which contains the variable. Let's have an example of an open mathematical sentence. Let's have number 1. 3x minus 2 equals 7. This statement is either true or false, because we cannot still know what is the value of x to satisfy that statement or that equation. All we have to do is to set an arbitrary values for x. For instance, if x equals 2, then 3x minus 2 equals 7 is false because 3 times 2 minus 2 is not equal to 7, which implies 6 minus 2 is not equal to 7, and therefore 4 really not equal to 7. How about if x equals 3? Then 3x minus 2 equals 7 is a true because 3 times 3 minus 2 equals 7, which implies 9 minus 2 equals 7, and therefore 7 equals 7. When a number replaces a variable in an equation to result in a true statement, that number is a solution of the equation. It seems like a problem. 3 times a number minus 2 equals 7. So what is the solution for that problem? So to find the solution for that problem, first you have to set arbitrary values for x to satisfy that equation. Okay? So therefore, 3 is the solution for that equation because it satisfies the equation or the statement. This time, let's have an example of an inequality as open mathematical sentence. And this will be considered as illustrative example number 2. X plus 5 is lesser than or equal to negative 1. This statement is either true or false. Class, what do you think the values of x to make that statement true? Do you have an idea? Okay, so first you have to do is to set an arbitrary values for the variable x. For instance, if x equals 1, then x plus 5 is lesser than or equal to negative 1. So it is false because 1 plus 5 is lesser than or equal to negative 1. So it's not lesser than or equal to negative 1 because it implies that 6 is lesser than or equal to negative 1. So it's not lesser than or equal to negative 1. So it's obvious that 6 is greater than negative 1. So that's why that statement is false under x equals 1. Let's have another one. If x equals negative 6, then x plus 5 is lesser than or equal to negative 1. This time it's true because negative 6 plus 5 is lesser than or equal to negative 1, which implies negative 1 is lesser than or equal to negative 1. But somebody may ask, oh, negative 1 is equal to negative 1. It's not lesser than. And take note, class, that the symbol of inequality is lesser than or equal to negative 1. So it satisfies. Let's have another one. If x equals negative 10, then x plus 5 is lesser than or equal to negative 1. Again, it's true Because negative 10 plus 5 is lesser than or equal to negative 1, which implies negative 5 is lesser than or equal to negative 1. Yes, class, negative 5 is lesser than negative 1. So that means negative 10 is one of the solutions for that inequality. When a number replaces a variable in an inequality to result in a true statement, that number is one of the solutions of the inequality. Take note, class, is one of the solutions of the inequality. The set of all solutions for a given inequality is called the solution set of the inequality. Oh, it's a set of solution, meaning it's more than one when it comes to inequality. Okay, negative 6 and negative 10 makes that statement or that inequality true. Therefore, negative 6 and negative 10 are part of the solution set. Let's have lesson number 1. It talks about properties of equality and inequality. What are the properties of equality? To find the solution of a given equation, we need to use the properties of equality. So, there is a property to find the solution of a given equation. We don't need to set an arbitrary values for the values of x or the variable to make the statement true. Okay? Let a, b, and c are real numbers. Let's have letter A, the first property of equality. It's known as reflexive property. A equals A. Oh, so it states that any number or expression is equal to itself. For example, 4 equals 4. Is 4 equals to 4? Yes. How about negative 7? Is it equal to negative 7? Yes. How about 1.5? 1.5 equals 1.5. Oh, reflexive property. It seems like you're facing a mirror. What will you see in front of the mirror is yourself. Am I right? Okay, let's proceed. Letter B. It's a symmetric property. If A equals B, then B equals A. Oh, interchanging the sides of an equation will not affect its equality. Okay? So, if A equals B, then B equals A. Okay, so it's just interchanging the sides of an equation. Exempli gratia. If b equals 2 plus 3, so then 2 plus 3 equals 5. Okay, so let's analyze. 5 is on the left side of this equal sign. And 2 plus 3 is on the right side. Then, on the statement, 2 plus 3 equals 5. So, from right side, it becomes on the left side. And 5 moved to the right side. Okay, it's just interchanging the left and right members of an equation. Another example, 3 minus 1 equals 2. And then, 2 equals 3 minus 1. Okay, so it's symmetric property. Okay, let's have letter C, known as transitive property. This time, it involves 3 expressions or numbers. And take note, A, B, C are real numbers. It's just a representation. Okay, let's continue. If A equals B and B equals C, then A equals C. So it tells us that if we have two things that are equal to each other, and the second thing is equal to a third thing, then the first thing is also equal to the third thing. Okay? For example, if 8 plus 1 equals 9 and 9 equals 10 minus 1, so we can say that 8 plus 1 equals 10 minus 1. Okay, let's elaborate. Take a look 8 plus 1, the first expression. 9 is the second expression. Then it becomes 9 equals 10 minus 1. The second expression is also equal to the third expression. So we can conclude that the first expression, 8 plus 1, is also equal to the third expression, 10 minus 1. Okay? So that's the transitive property. Okay, let's proceed. Letter D, addition property of equality, or in short, APE. This time, if two expressions are equal, A equals B, then A plus C equals B plus C. Okay? So it seems you are adding C on the left side of equation of equal sign and on the right side of equal sign. Okay? So what does it say? Says it states that if you add the same number or its additive inverse, okay? So it's a property of real number. Did you still remember properties of real number? To both sides of an equation, the sides remain equal. For instance, the equation continues to be true. Okay, so let's have an example. If 7 plus 4 equals 11, then 7 plus 4 plus negative 4 equals 11 plus negative 4. Okay, so it's true because you're just adding same number on the left and right member of equation. The first premise is that the two expressions are equal. So, meaning, if you add same number on the left and right member of the equation, so the equation really continues to be true. Okay? So that's addition property of equality. Letter E, multiplication property of equality. In short, MPE. If A equals B, okay, this time, again, two expressions are equal. Then AC equals BC. Class AC means A times C, and BC means B times C. Okay, it states that if you multiply the same number or its multiplicative inverse again, multiplicative inverse is one of the property of a real number. To both sides of an equation, the sides remain equal. The equation continues to be true. Okay, so let's have an example. If 3 times 4 equals 12, then 3 times 4 times 5 equals 12 times 5. So the first thing, two expressions are equal. Then multiplying third number, 5 on the left and right member of an equation, the equation continues to be true. Is it true? Okay, let's find. 3 times 4 times 5, so that's 60. 12 times 5 equals 60. Okay, so it satisfies. Let's now have the properties of inequality. To find the solution set of a given inequality, we need to use the properties of inequality. Again, let A, B, and C are real numbers. Addition property, API. If A is lesser than B, then A plus C is lesser than B plus C. Okay, if two expressions is lesser than to each other, adding on both sides by the same quantity or the same number, the result will still be lesser than. Example, if 4 is less than 5, then 4 plus 2 is less than 5 plus 2. Let's simplify. 4 plus 2, is it less than 5 plus 2, which is 7? This one is 6 and this one is 7. So 4 plus 2 is 6 and this one is 5 plus 2 is 7. Okay, let's have multiplication property of inequality. If A is lesser than B and C is greater than 0, then AC is less than BC, meaning that the C or the third number is positive. If the number is positive, the result will still be lesser than. Example, if 12 is less than 15, then 12 times 5 is less than 15 times 5. And that's 60, and this one is 75. 60 is lesser than 75, and that's correct. So it satisfies. Number 2, B.2, if A is lesser than B, but C is lesser than 0, then AC is greater than BC. So, what did you notice? The symbol reversed. Okay? So meaning, once you multiplied the left and right side of an inequality by a negative number, the symbol will reverse. For example, if 10 is lesser than 12, then 10 times negative 1 is greater than 12 times negative 1. Okay, originally that's lesser than, but once we multiplied by negative 1, the result will be greater than. Okay, let's simplify. 10 times negative 1 is negative 10 by multiplication of integers. 10 times negative 1 is negative 10. And this one is 12 times negative 1, it's negative 12. Is negative 10 greater than negative 12? Yes, that's correct. Okay, it satisfies. And take note, the properties of inequality will still hold true using the relation symbols lesser than or equal and greater than or equal instead of less than and greater than. Notice also that the inequality symbol is reversed when both sides of the inequality are multiplied by the same negative number. Let's sub lesson number 2. Finding the solution of a linear equations in one variable. Recall that if the same number is added to the left and right sides of an equation, the resulting sums are equal. We will now illustrate how this property is applied in solving linear equations in one variable. Solve for x. X minus 3 equals 6. What will be the value of x to make that statement true? By applying properties of equality, like addition property of equality, x minus 3 plus 3 equals 6 plus 3. By adding 3 on both sides. Why is it 3? 3 because we need to eliminate negative 3 on the left side of an equation, so that what remains on the left side will be the variable x. So, by taking the additive inverse of negative 3, and that's positive 3, because negative 3 plus positive 3, that's 0. What remains on the left side will be the variable x. And on the right side will be 6 plus 3 equals 9. So therefore, the value of x equals 9. Let's check. If x equals 9, so this will be 9 minus 3. And 9 minus 3 is equal to 6. Okay? So the solution of that equation is 9. Number 2, x minus 8 equals negative 1. What will be the additive inverse of negative 8? So that's positive 8. Because once you add negative 8 and positive 8, the result will be 0. And what remains on the left side will be the variable x. But don't forget to add 8 also on the right side, because we are just applying properties of equality, and that's addition property of equality. Add 8 to both sides. So the negative 8 plus 8, by adding addition of integers, the result will be 7. So the value of x equals 7. Let's check. 7 minus 8 equals negative 1. That's correct. So that means just add its additive inverse on both sides to isolate the variable x. Number 3. X plus 4 equals negative 3. This time, what is the additive inverse of positive 4? And that's negative 4. So we add both sides of an equation by negative 4. So x plus 4 plus negative 4 equals negative 3 plus negative 4. So x plus negative 4, so that's 0. So what remains on the left side will be the variable x. And negative 3 plus negative 4, so that's negative 7. Okay, by addition of integers. So the value of x equals negative 7. So by checking, if x is negative 7, so this will be negative 7 plus 4 is really equal to negative 3. So that's correct. Number 4, x plus 7 equals 2. So 7 plus negative 7. Because the negative 7 is the additive inverse of positive 7. And then again, don't forget to add negative 7 on the right side. So because 7 plus negative 7 will be x on the left side, but on the right side, by simply adding positive 2 and negative 7, applying addition of integers, the result will be negative 5. And that 9, 7, negative 7, and negative 5 are the solutions of a linear equations in one variable. And what property has been applied for these examples, for these illustrative examples? Okay, that's addition property of equality. Okay, let's erase this one. Recall that if the same number is multiplied to the left and right sides of an equation, the resulting products are equal. We will now illustrate how this property is applied in solving linear equations in one variable. Solve for x. X over 3 equals 5. You think of a number that once you multiplied on the right side and left side of an equation, what remains will be the variable x on the left side. And that's positive 3. So 3 times x over 3 equals 5 times 3. Okay, so this will be cancelled out. The 3 and the 3 will be cancelled out. So what remains on the left side will be the variable x. And just simplify 5 and 3 by multiplication. 5 times 3 equals 15. Okay, let's go back to this example. You think of a number. Once you divide it by 3, the result is 5. Is it 15? Yes, correct. Applying properties of multiplication, you will arrive at the correct answer. And take note that means just multiply its multiplicative inverse on both sides to isolate the variable x. What is the multiplicative inverse of 1/3? So that's 3. Okay? So how about number 6? What is the multiplicative inverse of 1 over negative 4? And that's negative 4. Because this will be cancelled out, what remains on the left side will be the variable x. And on the right side will be the product of negative 2 and negative 4. And that's positive 8. The positive 8 will be the value of x. Let's check. If x is 8 divided by negative 4, the result will be negative 2. And that's correct. Number 7. 3x equals 12. 3 times a number equals 12. So what is the number? What is the value of x? Then again, 3, its multiplicative inverse is 1/3. Multiplying both sides by 1/3, the numerical coefficient 3 will be cancelled out, or will be equal to 1, because 1/3 times 3 is 1. And on the other side will be 12 times 1/3, and 1/3 of 12 is 4. Okay, let's go back to the given equation. 3 times 4 equals 12. Okay, so that's correct. The correct value of x will be 4. The number is 4. Let's have number 8. -5 times a number equals -10. What is the number? Okay, so applying multiplication property by taking the multiplicative inverse of -5, and that's 1 over -5. So the result will be x equals 2. And then again, don't forget to multiply on the right side by the same number, 1 over -5. So -10 times 1, that's -10 divided by -5, so that's +2. -5 times a number equals -10. The number we found is 2. So -5 times 2, is it equal to -10? Yes, so that's correct. Okay. So number 9. Number 9 is 3x minus 2 equals 7. It seems like complicated, but we'll just have to apply properties of equation of inequality. First thing we have to do is to add both sides by 2 to eliminate that -2. So -2 plus 2 will be 0. So what remains on the right side will be 7 plus 2, and that's 9. 3x will remain on the left side and 9 on the right side. But you can apply another property, and that's multiplication property, by taking the multiplicative inverse of 3, and that's 1/3. 1/3 times 3x equals x, and 1/3 of 9 equals 3. So let's check. If x is 3, so this must be 3 times 3, and that's 9. 9 minus 2 equals 7. So it's correct. X is really 3. How about number 10? X divided by 2 plus 4 equals -2. Or a number divided by 2 added by 4 equals -2. So the first step is to eliminate +4 by applying addition property of equality. So that's -4. So -4 plus 4 will be 0, and -2 plus -4 will be -6. So x over 2 equals -6. And then again, the multiplicative inverse of 1/2 is 2. So we multiply 2 on both sides. So 2 times x over 2, so that's x. And -6 times 2 equals -12. Okay, let's check. If x is -12, or the number is -12, the number -12 divided by 2, that's -6, plus 4, the result will be -2. That's correct. Okay, let's have lesson number 3. Finding the solution set of a linear inequality in one variable. So it was recalled that a solution of a linear inequality in one variable depends on the given set of real number from which values for the variable can be taken. In addition, the set of real number that makes the inequality true when substituted to the variable is called the solution set of the inequality. Let us now apply properties of inequality. Illustrative examples. Let's have number 1. Solve for n. n minus 3 is greater than or equal to 1. n minus 3 plus 3 is greater than or equal to 1 plus 3. By adding 3 on both sides. So by applying addition property of inequality. So -3 plus 4, so that's 0. meaning what remains on the left side of this inequality will be n. And simplifying 1 and 3 by addition of integers, we will arrive at n is greater than or equal to 4. But in our expectations, the answer should be in a set builder notation. So that's why our conclusion will be thus n such that n is greater than or equal to 4. So it shows that the set of real numbers greater than or equal to 4 are the solution of the given inequality. Let's have number 2. N plus 7 is lesser than negative 6. Then n plus 7 plus negative 7 is lesser than negative 6 plus negative 7. So what was being added on both sides of this inequality? Correct. That's negative 7 on both sides. But 7 and negative 7, once we get the sum, the result will be 0. And on the other side, taking the sum of negative 6 and negative 7 will result to negative 13. And therefore, n is lesser than negative 13. And in a set builder notation, thus n such that n is lesser than negative 13. So what are the possible values of n? Yes, those are lesser than negative 13. And what are they? Correct. That's negative 14, negative 15, negative 16, to negative infinity. But take note, decimals are also included in the set of solution, like negative 13.1, negative 13.2. Those are also solution of that inequality. But let's check, like negative 15. Negative 15 is lesser than negative 13. Okay, let's check. If n is negative 15, so this must be negative 15 plus 7. And what is negative 15 plus 7? Correct, that's negative 8. So negative 8 is lesser than negative 6. So therefore, it's satisfied. How about those not solution of this inequality? For example, if it is lesser than negative 13, so 5 is not a solution for this inequality. Let's try 5. But take note, it's not a solution. So n will be 5 plus 7. So what is 5 plus 7? So it's 12. Is it lesser than negative 6? No, because it's not a solution for that inequality. Let's have number 3. A number divided by 5 is greater than negative 8. Okay, so what will be multiplied on both sides of inequality? Correct. So it should be the multiplicative inverse of 1/5. The multiplicative inverse of 1/5, so it's 5. Okay, so multiply both sides by 5 to eliminate, or this will be cancelled out. So what remains on the left side of this inequality will be the variable n. And on the right side, applying multiplication of integers with regards to sign, the result will be negative 40. And thus, n such that n is greater than negative 40. And what are the greater than negative 40? Like negative 39, negative 38, negative 37, positive 1, 0. Those are solution of this inequality. And what are those that are not solution of this inequality? those will be numbers on the left side of negative 40, like negative 41, negative 42. Those are not solution of this inequality. But let's try 100. 100 is a solution of this inequality. So if n is 100, divided by 5 equals 20. So is 20 greater than negative 8? Yes. Okay, so 100 is really a solution for this inequality. Let's have number 4. Negative 6n is greater than or equal to 18. Negative 6n, its numerical coefficient is negative 6. So, and therefore, what will be its multiplicative inverse? Its multiplicative inverse is 1 over negative 6, or you can have negative 1 over 6. Okay, so we multiply both sides of this inequality by applying multiplication property of inequality by 1 over negative 6, or by the multiplicative inverse of negative 6, because 1 over negative 6 times 6, that would be 1, and the numerical coefficient of n will be 1. And on the other side, negative 1/6 or 1 over negative 6 of 18, so that's negative 3. And therefore, the solution set of this inequality is n such that n is lesser than or equal to negative 3. Okay. Let's have example number 5. This time, there are 3 expressions. There is a middle one, the left side, and on the right side. So on the left side will be 2n plus 1 is greater than negative 13, but lesser than 9. Okay, so first you have to add negative 1 on all sides, meaning on the left side, on the middle one, and on the right side. Why is it negative 1? Because we have to eliminate positive 1 first. Okay, by adding its additive inverse. So combining 1 and negative 1, the result will be 0. And what remains on the middle part will be 2n. And on the right side, on the left side will be the sum of negative 13 and negative 1, and that's negative 14. Whereas on the right side, 9 and negative 1 will be positive 8. Okay, by simplifying all sides. And then, we will have to apply multiplication property of inequality. What will be multiplied on all sides of this inequality? Yes, correct. That's 1/2. Okay, so because the multiplicative inverse of 2 is 1/2. Okay, so 2n times 1/2, so that would be n. And negative 14 times 1/2, or 1/2 of negative 14 is negative 7. And 1/2 of 8 is 4. And therefore, n such that n is greater than negative 7 but lesser than 4. Okay? So, what are the possible values of n? So, the possible values will be, if it is integer, so that's negative 6, negative 5, negative 4, say 1, 2, and 3. Take note, Decimals are also solution set for this inequality. But let's try to check whether the solution set or one of its solution can satisfy for this inequality. Let's try negative 5. If n is negative 5 based on its solution set, so 2 times negative 5, so that's negative 10 plus 1, so it's negative 9. So it's negative 9. Okay, negative 9. Okay, it's hard to write here. So negative 9 is greater than negative 13, but lesser than 9. Okay, let's erase this one first. Okay, let's try 2. If n is 2, so this must be 2 times 2. 2 times 2 is 4 plus 1, so it's 5. Okay. So, okay. So this will be negative 13. Oh my. Okay. So is 5 greater than negative 13? Yes. Is 5 lesser than 19? Yes. Okay. So it satisfies. But how about those are not solutions of this inequality? For example, let's say 5. If it is 5, so this must be 2 times 5. And that's 10 plus 1, so that's 11. Okay. Is 11 less than 9? Okay. For this part, so it will not satisfy. So that's why positive 5 is not the solution for this inequality. Okay. So that's how you will solve a linear equation, linear inequality using properties of inequality. This part will be the summary of the lessons. Remember, a linear equation in one variable is one which can be written in the form ax plus b equals 0, where a and b are real number constants and a should not be equal to 0. When a number replaces a variable in an equation or inequality to result in a true statement, that number is a solution of the equation or inequality. But the set of all solutions for a given inequality is called the solution set of the inequality. Third, in finding the solution and solution set of a linear equation and inequalities, it is important to remember the following properties. And that's the properties of equality. Let A, B, and C are real numbers. The first property is the reflexive property, which states that any number or expression is equal to itself. Second, symmetric property. Interchanging the sides of an equation will not affect its equality. Number 3, transitive property. Tells us that if we have two things that are equal to each other, and the second thing is equal to a third thing, then the first thing is also equal to the third thing. Number 4, addition property of equality. States that if you add the same number or its additive inverse to both sides of an equation, the sides remain equal. The equation continues to be true. Number 5, multiplication property of equality states that if you multiply the same number or its multiplicative inverse to both sides of an equation, the sides remain equal. The equation continues to be true. So the properties of equality is used to solve the equation involving one variable. This time, it's your turn. You will now answer properties of equality and how to solve equation using properties of equality. Another property is known as the properties of inequality. Let A, B, and C are real numbers. Addition property. If A is lesser than B, then A plus C is lesser than B plus C. So, adding same number on the left and right members of inequality, the result will still be the same. The multiplication property. Letter A. If A is lesser than B and C is greater than 0, meaning C is positive, then C times A is lesser than B times C. The symbol lesser than is still the same. All will remain lesser than. Letter B. If A is lesser than B and C is lesser than 0, meaning C is negative numbers, then C times A is greater than B times C. So, the symbol will reverse. And that's the properties of inequality. So, properties of inequality is also used to solve problems involving linear inequalities in one variable. Okay, this time let's have your activities. Activity number 1, tell me. Tell what property of equality and inequality is illustrated in its statement. If you still remember the expectations before we start this lesson. Given that if 3 times negative 1 equals negative 3 and negative 3 equals negative 3 times 1, then 3 times negative 1 equals negative 3 times 1. You just have to illustrate or tell what property has been illustrated for item number 1, number 2, number 3, 4, 5, and 6. The properties are just the reflexive property, the transitive property, the symmetric property, the addition property of equality, and the multiplication property of equality. But when it comes to inequality, we have addition property of inequality and the multiplication property of inequality. Let's have letter B. Fill in the blanks with correct expressions indicated by the property of equality and inequality to make a true statement. For instance, number 7. If 2 plus 5 equals 7, then 7 equals blank. It should be in a symmetric property. If 80 plus 4 equals 84, then the quantity 80 plus 4 multiplied by 2 equals 84 multiplied by what number? And it should be the multiplication property of equality. And for number 9, what expression should be written in this blank? But it should rely on the addition property of inequality. For number 10, you have to consider the multiplication property of inequality. Activity number 2, supply me. Solve the following equations by supplying the missing terms. You have the procedure. X plus 13 equals 20. X plus 13 plus blank equals 20 plus blank equals blank. Then your reason. The reason will be the properties. And that's 2.5 points. Take note, that's 2.5 points. Note the score in procedure will be 0.5 point each, whereas in the reason will be 1 point each. Okay, so 0.5, 0.5, 0.5, and another 1 point. So that's 2.5 points. Okay, so number 1, number 2, number 3, number 4, it's 2.5 points each and a total of 10 points for activity number 2. For letter B, find the solution of the following linear equation in one variable. Show your concrete solution. Sample rubrics: x minus 3 equals 6, x minus 3 plus 3 equals 6 plus 3, and that's 0.5 point. And your final answer will be 1 point. Okay, 1.5 points per item, items number 11 and 12. Number 11 and 12. Okay, number 11 and 12. No, the items 11 and 12 is 2.5 points. Whereas items 1 to 10 is 1.5 points each and a total of 20. You have to show your concrete solution or your step by step. And this one is the example. Activity number 3, find me. So find me again, it's in an inequality. Okay? So your final answer will be in a set builder notation. Show your concrete solution and conclusion in a set builder notation. So thus n is great n such that n is greater than -7 but less than 4. Less than 4. A total of 14 points for activity number 3. This time you have to check your understanding. So you have to fill up the following blank, the line for your respective answer. And we have the post test items 1 to 5. So answer all the item for our post test. Write the chosen letter on a separate sheet of paper. And you also have to answer the reflection. Answer the following questions as much as you realize the importance of the lessons. How you relate an equation and inequality in real life, or equation or equality in real life situation. Give at least 3 synonyms for inequality and provide each a meaning. Can you give a situation wherein you apply the properties of equality and inequality? Okay, write it down here. That ends the presentation of today's lesson. This time, I will give you 1 hour to answer all the activities, check your understanding, post test, and the reflection on your answer sheet. Okay, goodbye for now. See you next time.